For the last video on this worksheet, we're going to look at an application. Okay, so an application with inequalities. There are a couple that are fairly typical that could come up, but one that you'll definitely, well, I don't want to say definitely, one that you would frequently be exposed to when you're dealing with linear inequalities in two variables would be something like this. So it says, example 4, many elevators have a capacity of 4,500 pounds. That's as much as it can safely carry. Okay, so it says use the information to answer the questions below. So for part A, it says if the average child weighs 50 pounds and the average adult weighs 160 pounds, write an inequality that represents the number of children X and the number of adults Y that will keep the elevator from becoming overloaded. So basically, if we have a certain number of kids and a certain number of adults and we want to maintain that capacity, we do not want to go over the capacity, what number of kids, what number of adults could we have? Now, we're taking some liberties here. We know not every kid weighs 50 pounds. We know not every adult weighs 50 pounds, but just taking averages, this is what we're going to go with. So we know that X is the number of children. We know that the number of adults is going to be Y. And each kid we're saying weighs approximately 50 pounds. So we would take 50 times the number of kids, so 50X. We would add that to 160 times the number of adults Y. And we would want this to be less than or equal to 4,500. So we can equal 4,500, we can be less than 4,500, we cannot safely be over 4,500 and trust this elevator to do its job, okay? So we've done our job here for part A. Part B says, select an ordered pair that satisfies the inequality. What are the coordinates and what do they represent in this situation? Now, this is something you could do. You could do this by hand. You could just play around and pick different values for X or Y. You could also use a graphing calculator, but I want to take this opportunity to introduce you to something called Desmos, okay? Desmos is amazing. It does a lot of stuff. It's really good for helping you learn. I do want to caution you, don't overuse it, okay? Because if you overuse it, you won't learn. And then when it comes time for a test, you're not going to necessarily have Desmos at your disposal. So you really do need to learn this stuff, but this is a good time to show you how to use Desmos. So we have, let me share here. Right here. Okay, so here we have Desmos. It's just Desmos, desmos.com, and there's this option right here to open the graphing calculator. That's what we want to do, okay? And then you can just type in any equation, and that's what's really nice about this. If you're using a graphing calculator, you sometimes have to do some work to your equation or your inequality before you can type it in. Desmos is really nice. You just type it in, okay? So remember, we had each kid was X, and they weighed approximately 50 pounds. To that, we were going to add the weight of an adult, which we decided was an average of 160 pounds, and we were going to multiply that by the number of adults Y. And that had to be less than or equal to 4,500. Now, a regular keyboard has a less than symbol and a greater than symbol, so we would have an issue typing that in. But if you look down here in the lower left-hand corner, we have the keypad. Just click that, and it's going to pull up a keypad which has extra buttons that are going to be nice for us. So we want to choose less than or equal, and then we're going to type in 4,500. So notice it types it in, it even does the shading, but you're like, what in the heck? Why is my whole screen pink? Well, we need to tweak this. This window goes from -10 to +10 on the x-axis, incrementing by 2. And then it goes from -6 to +6 on the y-axis, incrementing by, again, 2. We need to see much bigger values than that because remember, we can go all the way to 4,500. So depending on what x and y is, we have a weight that has to be 4,500. So we need to tweak our window here. We also need to think, can we have negative kids and negative adults? Well, no. So this negative x-axis and this negative y-axis, they don't really apply to us because remember, x and y apply to just people. People can't be negative. They're either there or they're not, but they're not negative. Okay, so we need to tweak our settings here. So if you go to this little wrench tool, it allows you to tweak your graph settings. So let's go down here to where it says X and Y axis. Well, we don't really need this -10. So let's say that our X axis starts at 0. Let's say the same thing for our Y axis. And as you type things in, you can see kind of behind me, it's going to start changing them. So we want our X's and our Y's to start at 0. Okay. And then let's say we go to, I don't know, maybe 100 each. I think 100 is excessive. I don't think we're going to need 100. In fact, we're not going to need anywhere close to 100. So let's change that to 50. So we can play around here. We're going to change both of these to 50. Okay. Now, what's nice here is we can see the pink part represents our solution. Those are the values of adults and kids that make sense to us. Anything more than that, so if we go higher than this point on the y-axis, we're going to be too big. And if we go way over here on the x-axis, we're going to be too big. So we have to stay within this pink region, okay? Now, when you see over here the step, it will allow you to increment by, like, let's say 5s. So let's increment both of these axes by 5s, okay? And then you can just click and it takes you outside of this. Now, if I wanted to, I could go further along the x-axis if I wanted. I could say, okay, on the x-axis, let's go to 100. Let's see what happens there, okay? Now we can see the full graph, okay? Now remember, we can't have negative x, we can't have negative y, because then we have negative people. We also can't have like weird like 3.5x, like x can't be a decimal because you can't have like half a kid. You either have a whole kid on the elevator or you have no kid on the elevator, but you can't have like a fraction of a kid. Okay, so if you start clicking in here, it'll give you different points. So like if I click on this line, it'll give me like the point that I'm at. Okay, so like right here, that seems cool. We're within our pink region, but we can't have 21.9 kids and 21.28 adults. That's not reasonable. You can't have fractions of people and adults. But I happen to see this point right here. It seems to be right at 10 and 25. So that makes sense. I can have 10 full kids and I can have 25 full adults. So I like that point. I'm going to choose that one. I think it's reasonable. I could also choose any point underneath this. So I could choose this point right here. Well, it's not going to show me, but I could choose like 10, 10. 10 kids, 10 adults. I'm going to be way less than 4,500, but I'm not over 4,500. So basically what's happening here is any of these points that are exactly on the line, as long as we get from 0 to 90 on the x-axis and 0 to like, I don't know, 36 on the y-axis, we're good, okay? So the points on the line are going to be the values for adults and kids that are exactly 4,500. Anything below that is going to be the number of adults and the number of kids that are going to be less than 4,500. So as long as you pick an ordered pair that has whole numbers in it, you're good. So I could say, okay, I could have 25 adults and no kids. That works. I could have 75 kids and no adults. That would be weird to have that many kids on an elevator alone, but you could do it within the constraints of this particular elevator. So you just need to pick some value in this pink region that makes sense. Again, you can't pick negatives for people, so you can't go below the x-axis or behind the y-axis. But as long as you stay in this pink region or on the actual line, you're going to have a value that works. Okay, so let's go back to the worksheet. So there was a point that we found that was right on the line. We found the ordered pair 10, 25. Okay, so this says if x equals 10 kids and y equals 25 adults, that's an L, not a T, we are at capacity. Meaning if I take 50 times 10 plus 25 times 160, I equal exactly 4,500. Okay, so I'm still within capacity. We're pushing it. We're getting to that not so safe region, but we're still within capacity. If I chose some other ordered pair, let's say I chose 10 kids and 15 adults, I would be less than 4,500 if I plug that into the inequality. So again, that pink region really like makes it kind of clear like what the solution is. Now, we do have to take into account the real world aspect here. You can't have negative kids, you can't have negative adults, okay? You can't have partial kids, you can't have partial adults. But as long as you pick an ordered pair within that pink region on the line or below it, you're going to be within the capacity of this particular elevator, okay? So again, this is kind of twofold. It gives you a real world application where a linear inequality is applicable, but it also gave us an opportunity to kind of play around with Desmos, which is really, really helpful. It's nice to get a visual of what's going on in a lot of cases. Just don't, I really do caution you, don't overuse your Desmos, okay?